Thanks. So, hello everyone. We would like to thank the attendees for coming to listen to our talk, as well as to Habitat Marty and Dr. Julia for their kind invitation to participate in the annual Space Habitat event. Throughout our talk, we will present the advances that the Space Technology MX organization has made regarding current research that seeks to create solutions for one of the greatest challenges in the space sector, which is the production of food for long-duration space missions. Okay, so first, I will talk about a device that will allow the growth of crops in space, and then my colleague will talk about the cultivation of microalgae for future astronaut consumption. Yeah. So, well, what are the reasons why humans should colonize Mars? Or one of the most important reasons why to do this. So, well, I think the most important one is to ensure the survival of our species, right? And well, Elon Musk has, in a press conference, when he was asked the same question, he made a very good answer that I would like to talk about right now. Which is, well, what will we do if an asteroid like the one that finished with the dinosaurs arrived today or tomorrow? Or what if some other catastrophic event happened right now, which ended the human civilization as we know right now, such as, well, I don't know, a war, a international conflict, famine, a pandemic, or something like this that we have that could end the civilization in any moment, right? So if something like this happens, we have to have a plan B, right? A place to go, a place where our human civilization can continue, right? And what a better option than one of our closest neighbors, right? Mars, which I think it would be the best plan B for us to go and well, to rebuild our civilization if something catastrophic comes to occur in our planet. So, with this in mind, with the need for human colonization of the red planet of Mars and the necessity to produce food for long-term missions, gave rise to the Biocolchon Space Garden project, which consists of a device that will allow the growth of various species of plants to consumption on the red planet. This device has on the outside a thermal insulation bag made of neoprene and denim that protects its surroundings from contamination with pathogens. Inside, it has a biodegradable bag that compacts the substrate made of agrolite and a biodegradable sponge and the nutrient solution. The equipment has small hoses that provide the plant with the different solutions it requires. And the device has humidity and temperature sensors that are part of a monitoring system that represents a novelty when compared to other space garden models. In the image, we can appreciate in the right the latest model for the Biocolchon Space Garden device. And on the bottom, we can see one of the radishes that was grown inside this device. In addition to what has already been mentioned, a control console has also been developed. It complements the Biocolchon device with the aim of generating a safe environment for the species that is being cultivated. It is equipped with a ventilation system, humidity and gas sensors, lighting in different ranges of the electromagnetic spectrum, and walls that allow the system to achieve thermal insulation and retain any dripping that may occur. As well, in the image, we can appreciate, well, in the middle, this control console, the continuous control console, and inside some plants being grown there, and well, in the right, some little crops being also grown there. Okay, so the initial selection of species to be tested in the system were lettuce, potato, and corn. reaching not only the planting and germination of the seeds, but their complete development. These species were selected for their high nutritional content compared to other plants intended for human consumption. It has been decided to additionally incorporate amaranth and radish in our tests because the former crop is considered a superfood, thanks to its excellent nutritional content, while radish provides significant amounts of water, protein, and fiber. In the table, we can appreciate the content of proteins, carbohydrates, lipids, water, and fiber that each of the selected species provides. Okay. Plants are provided with a nutrient solution that is mainly composed of distilled water and agromil, which contains growth hormones and promotes accelerated plant growth. In the first 10 to 15 days, the NEM solution is also provided, which prevents pests. About 15 days after plant germination, the leachate collected in a tray below the biodegradable bag is reapplied to the plant. And if it is in optimal conditions, the leachate will contain mainly humic and fulvic acids, apart from the elements shown in the right table with a pH of 8. Okay, so in the drawer, there are red and blue colored lights, LED lights. In the germination stage, white light LEDs are used during the day and colored LEDs at night in order to accelerate their growth. Later on, when they finish germination, only white LEDs are used during the day. Photoperiods are adapted to the plant's current stage of growth. At the moment, UV light supply. There are loop sensors inside the console to measure the amount of light that reaches the plant in order to verify that the amount of light they need is being emitted. This is important because too much light can cause the leaves to turn yellow. And in the console, the intensity of light can be adjusted depending on the plants to be grown. Right? Corn needs about 10,000 lux, lettuce around 5,000 lux, and radish 12,000 lux. This is adjusted. And finally, well, in this graph, we can see the measurements per day of 4 parameters that were obtained throughout the month of July 2021 in radishes that were developed within the bioculture system. Green and purple bars represent plant growth in centimeters and water supplied in milliliters, respectively. On the other hand, the pink and orange lines show the temperature in degrees Celsius and the percentage of internal humidity of the system, respectively. It is important to note that as the plant increases in size, its water consumption goes up as well. Okay, so now going on to the second part of the session, I will give the screen for my colleague Alejandro, so he can talk more about this new project about microalgae growth that we're developing in our company.
Hello, everyone. Good morning, everyone. On this occasion, first of all, thank you very much for the opportunity to give us to a space talk about your project in the general. As we have already heard, the biomass stress project consists of another point. Bioreactors are focuses on purifications on air and creation of biomass to generate into energy. The next, please. Here we seen some main is the questions they are generated of the results of one microalgae here. Is what are microalgae? Well, in these points and 3 points is the microalgae here microscopic and invisible to naked eye. They are phytoplankton, typical found on the freshwater and the marine systems, living for water and sediments. The next, please. We are presently and imagine wide a part of the great variety of elks that exist around the world, and the only some have been studied for NASA, as carried on studies of some how they generate a certain substance for to combat for disease. Uh, the next, please. In this imagine can see experiments for International Space Station for astronaut research in this type of macroalgae. Of the thousands of species that exist in the world, we are focused on the one species, in particular spirulina, due to its great adaptability and any environment and condition. This makes them perfect to be studied in space missions. The next. For our part, we also making progress in terms on air purification. We are studying underground tests to carry biomass productions. But in this imaging, we can see the collection of the samples in the high populated part of the Mexico City and how we have carried on the ore disease. And this imaging, please. Yes, and this imaging, we can see regulating for the samples and the species and the microalgae and concrete and these parts in Mexico City is Xochimilco. And the first imagine how can you see as the taster for salinity and in second imagine and third imagine is the how can you see recollection to alga part for the ground and the species. And the next, please. Los research objects from operating parameters, analysis on the classification of the species, ground teams labs, and continuing and installations methods and culture preparations. And the next. Finally, and to finish, here our present project for the first analogous space station analogous station in Mexico, and here diagrams will be in the future. One more for a moment, and then will be, and we're waiting for your questions.
Thank you very much for your attention, and we're happy to answer any questions that you may have.